Welcome to the fascinating world of debugging and testing. In this video, we'll explore the essential skills every developer needs to master for building reliable software. Debugging is more than just fixing errors. It's about understanding how your code works and why it sometimes doesn't. Testing, on the other hand, ensures that your software behaves as expected in different scenarios. Together, these practices form the backbone of quality software development. Whether you're a beginner or an experienced coder, refining your debugging and testing techniques can save you countless hours and headaches. Let's begin our journey by understanding the basics and why these skills are so crucial. Debugging is the process of identifying, isolating, and fixing problems or bugs in your code. It's a systematic approach that involves careful observation, logical reasoning, and sometimes a bit of intuition. Bugs can range from simple syntax errors to complex logical flaws that only appear under certain conditions. Effective debugging requires patience and a keen eye for detail. By learning to debug efficiently, you not only fix issues faster but also deepen your understanding of how your code operates. Let's look at some common types of bugs and how they can impact your software. Bugs come in many forms. Syntax errors are the easiest to spot. They occur when your code doesn't follow the rules of the programming language. Logical errors are trickier. Your code runs, but it doesn't do what you expect. Then there are runtime errors, which only show up when the program is running, often due to unexpected input or conditions. Understanding these types helps you approach debugging with the right mindset. Each type requires different strategies and tools to identify and resolve. Recognizing the nature of a bug is the first step toward an effective solution. Successful debugger approaches problems with curiosity and persistence. Instead of getting frustrated by errors, view them as opportunities to learn more about your code. Break down complex problems into smaller, manageable pieces. Ask yourself questions about what the code is supposed to do versus what it's actually doing. This mindset not only helps you solve current issues, but also prepares you to prevent similar problems in the future. Remember, every bug you fix is a step toward becoming a better developer. Modern development environments offer a variety of tools to help you debug efficiently. Integrated debuggers allow you to set breakpoints, step through code, and inspect variables at runtime. Logging tools help you track the flow of your program and identify where things go wrong. There are also stack analysis tools that catch potential issues before you even run your code. Familiarizing yourself with these tools can dramatically speed up your debugging process and improve your productivity. Breakpoints are a fundamental feature in most debuggers. By setting a breakpoint, you tell the debugger to pause execution at a specific line of code. This allows you to examine the state of your program at that moment, checking variable values, the call stack, and more. Breakpoints are especially useful for isolating the exact location where things go wrong. By stepping through your code line by line, you can observe how data changes and identify the root cause of bugs. Logging is another powerful debugging technique. By adding log statements to your code, you can record important events, variable values, and error messages as your program runs. This information is invaluable for tracking down elusive bugs, especially in complex systems or when debugging remotely. Effective logging involves choosing the right level of detail. Too little and you miss important clues, too much and you get overwhelmed. Learn to strike the right balance for your project. Stack analysis tools examine your code without running it, looking for potential errors, code smells, and security vulnerabilities. These tools can catch issues like unused variables, unreachable code, or risky patterns before they become real problems. By integrating stack analysis into your workflow, you can maintain higher code quality and reduce the number of bugs that make it into production. Popular tools include linters and code analyzers tailored to specific programming languages. Testing is the process of evaluating your software to ensure it works as intended. It involves running your code under various conditions and checking the results against expected outcomes. Testing helps you catch bugs before your users do and gives you confidence in your code. There are many types of tests, each serving a different purpose. By understanding the fundamentals of testing, you can design more robust and reliable software. Unit testing focuses on individual components or functions of your code. By writing tests for small, isolated pieces, you can quickly identify where problems occur. Unit tests are usually automated, running every time you make changes to your code. This ensures that new updates don't break existing functionality. Well-written unit tests make your codebase more maintainable and easier to refactor in the future. Integration testing checks how different parts of your application work together. While unit tests focus on individual pieces, integration tests ensure that these pieces interact correctly. This is especially important in complex systems where components depend on each other. Integration tests can reveal issues that unit tests might miss, such as data mismatches or communication problems between modules. System testing evaluates the entire application as a whole. It simulates real-world usage to ensure that all components work together seamlessly. This type of testing is usually performed by a separate testing team and covers both functional and non-functional requirements. System testing helps you catch issues that only appear when the application is fully assembled and running in its intended environment. Acceptance testing determines whether your software meets the requirements and expectations of the end user. These tests are often based on user stories or business requirements and are typically performed by stakeholders or clients. Passing acceptance tests means your software is ready for release. This stage is crucial for ensuring customer satisfaction and delivering value. Testing can be done manually or automatically. Manual testing involves a person running tests and checking results, which is useful for exploratory testing or when automation isn't practical. Automated testing uses scripts or tools to run tests automatically, making it faster and more consistent. Most modern development workflows use a combination of both approaches to achieve the best results. Test-driven development, or TDD, is a software development approach where you write tests before writing the actual code. This method encourages you to think about requirements and design up front. By writing tests first, you ensure that your code is always testable and meets the desired specifications. TDD can lead to cleaner, more reliable code and faster debugging. Good test case clearly defines what is being tested, the input values, expected results, and any setup or teardown steps. Well-written test cases are easy to understand and maintain. They help you catch edge cases and ensure comprehensive coverage. Investing time in writing quality test cases pays off by making your testing process more effective and reliable. Test coverage measures how much of your code is exercised by tests. High coverage means most of your code is tested, reducing the risk of undetected bugs. However, 100% coverage doesn't guarantee bug-free software. Quality matters as much as quantity. Use coverage tools to identify untested areas and improve your test suite over time. Mocking and stubbing are techniques used in testing to simulate parts of your system that are difficult to test directly. Mocks imitate the behavior of real objects, while stubs provide predefined responses. These techniques help you isolate the code under test and focus on specific scenarios, making your tests more reliable and faster to run. Continuous integration is a development practice where code changes are automatically tested and integrated into the main branch frequently. CI tools run your test suite every time you push new code, catching issues early and ensuring that your software remains stable. Adopting CI helps teams collaborate more effectively and deliver higher quality software. Debugging is often a collaborative effort, especially in large projects. Sharing knowledge, discussing issues, and reviewing code together can lead to faster and more effective solutions. Tools like version control and code review platforms make it easier to track changes and understand the history of bugs. Teamwork in debugging not only solves problems but also helps everyone learn and grow. Pair programming involves two developers working together at one workstation. One writes code while the other reviews each line in real time. This approach is excellent for catching bugs early and sharing knowledge. It also improves code quality and helps team members develop better debugging and testing habits. Pair programming can be especially helpful when tackling complex or unfamiliar code. Code reviews are a critical part of maintaining high-quality software. By having peers review your code, you can catch bugs, improve readability, and ensure adherence to best practices. Code reviews also foster a culture of learning and accountability within the team. Regular reviews help prevent issues from slipping through and make debugging easier down the line. Regression testing ensures that new code changes don't break existing functionality. Whenever you fix a bug or add a feature, it's important to run your test suite to verify that everything still works as expected. Automated regression tests are especially valuable in large projects, where manual testing would be too time-consuming. Performance testing evaluates how your software behaves under different loads and conditions. It helps you identify bottlenecks, memory leaks, or slow operations that could impact user experience. By simulating real-world usage, you can ensure your application remains responsive and reliable, even as demand grows. Security testing is crucial for protecting your software and its users from vulnerabilities. This type of testing checks for weaknesses that could be exploited by attackers, such as injection flaws or insecure data storage. Automated security tests and code analysis tools can help you identify and fix issues before they become serious threats. Usability testing focuses on how easy and intuitive your software is for users. By observing real users as they interact with your application, you can identify pain points and areas for improvement. Usability testing helps you create software that not only works correctly but also provides a great user experience. Exploratory testing is an informal approach where testers actively explore the application without predefined test cases. This method is great for discovering unexpected issues and learning more about how the software behaves in real-world scenarios. Exploratory testing complements automated tests by catching edge cases and usability problems. Clear and detailed bug reports are essential for efficient debugging. A good bug report includes a description of the problem, steps to reproduce it, expected and actual results, and any relevant screenshots or logs. Well-documented bugs help developers understand and fix issues faster, improving the overall quality of the software. Not all bugs are created equal. Some issues are critical and must be fixed immediately, while others are minor and can wait. Prioritizing bugs helps you allocate resources effectively and address the most important problems first. Consider factors like severity, impact, and frequency when deciding which bugs to tackle. Finding the root cause of a bug is key to preventing it from happening again. Root cause analysis involves digging deeper to understand why a problem occurred, not just fixing the symptoms. This process often reveals underlying issues in design, process, or communication that need to be addressed for long-term quality. Good documentation supports both debugging and testing efforts. Clear code comments, design documents, and test plans make it easier to understand how the software works and why certain decisions were made. Well-documented projects are easier to maintain, debug, and test, especially as teams grow or change. Version control systems like Git are invaluable for debugging. They allow you to track changes, revert to previous versions, and collaborate with others. By reviewing commit histories, you can identify when and where bugs were introduced, making it easier to isolate and fix issues. Automated build systems compile and test your code automatically whenever changes are made. This ensures that errors are caught early and that your software is always in a deployable state. Build automation saves time, reduces manual errors, and supports continuous integration and delivery practices. A test environment is a setup that mimics the production environment where your software will run. Testing in a realistic environment helps you catch issues that might not appear in development. It's important to keep test environments up to date and as close to production as possible for accurate results. Flaky tests are tests that sometimes pass and sometimes fail without any code changes. These can be caused by timing issues, dependencies, or environment inconsistencies. Identifying and fixing flaky tests is important for maintaining trust in your test suite and ensuring reliable results. Debugging in production is challenging because you have limited access and can't disrupt users. Use logging, monitoring, and error reporting tools to gather information without affecting performance. Careful analysis of logs and metrics can help you pinpoint and resolve issues quickly, minimizing downtime. Monitoring tools track the health and performance of your software in real time. Alerts notify you when something goes wrong, allowing you to respond quickly. Setting up effective monitoring and alerting systems is essential for maintaining high availability and catching issues before they escalate. Every bug or failure is an opportunity to learn and improve. Conduct postmortems after major incidents to analyze what went wrong and how to prevent similar issues in the future. Sharing lessons learned helps the whole team grow and leads to more robust software over time. Debugging and testing are skills that improve with practice and continuous learning. Stay updated with new tools, techniques, and best practices by reading articles, attending workshops, and engaging with the developer community. The more you learn, the more effective you'll become at building high-quality software. In fast-paced development environments, it's tempting to skip thorough testing or debugging to save time. However, cutting corners often leads to more problems down the road. Strive to balance speed with quality by integrating testing and debugging into your regular workflow. This approach leads to more stable and maintainable software. Feedback from users, testers, and team members is invaluable for improving your software. Encourage open communication and make it easy for people to report issues or suggest improvements. Incorporating feedback into your debugging and testing processes leads to better products and happier users. Organization is key to effective debugging and testing. Use task trackers, bug databases, and test management tools to keep everything in order. Staying organized helps you prioritize work, track progress, and ensure that nothing falls through the cracks. Software development is always evolving, and so are debugging and testing practices. Be open to new tools, methodologies, and ideas. Adapting quickly to change ensures that your skills and processes remain relevant and effective in a rapidly changing industry. Take time to celebrate your successes, whether it's fixing a tough bug, achieving high test coverage, or releasing a stable product. Recognizing achievements boosts morale and motivates you and your team to keep striving for excellence. Every milestone is a step toward mastering the art of debugging and testing. We've now explored the core concepts, tools, and best practices for debugging and testing. Remember, these skills are essential for building reliable, high-quality software. Keep practicing, stay curious, and continue learning. The journey to mastering debugging and testing is ongoing, but every step you take brings you closer to excellence. Thanks for joining this exploration. Now go and apply what you've learned.